Solve the equation 3 sine squared 2 theta plus 8 cos 2 theta equals 0 for theta from 0 to 180 degrees. The trick to solving these equations is to turn everything into one type of trigonometric function, either all sine, all cos, or all tan. In this case, we should be trying to turn everything into cos 2 theta. From the formula sheet, we have cos squared theta plus sine squared theta equals 1. This means that cos squared 2 theta plus sine squared 2 theta must also equal to 1, and therefore we can rearrange for sine squared 2 theta. And then we can use this to substitute it back into the equation that we want to solve in place of the sine squared 2 theta. And now we have everything in terms of cos squared 2 theta. The next step is to try and solve for cos 2 theta. However, we can't make cos 2 theta the subject of the formula because we have a cos squared 2 theta term and a cos 2 theta term. Therefore, if we let x equals cos 2 theta, we can rearrange the expression to make it look like a quadratic and solve it like a quadratic by factorizing. After solving it like a quadratic, we have two answers for x, or two answers for cos 2 theta, which is our x, as minus 1 over 3 and 3. However, cos 2 theta equals 3 is impossible, as values for sine and cos only are between minus 1 and 1. This means that we only have one value for cos 2 theta, which equals minus 1 over 3. To find 2 theta, we can do the inverse cos of minus 1 over 3, which gives us 109.47. Whenever we do inverse cos, inverse sine, or inverse tan, there can always be more than one answer, depending on the range of values we are looking at. The range of theta is from 0 to 180. But in this case, we're working with 2 theta, therefore the range for 2 theta must be from 0 to 360. So we need to find all angles from 0 to 360 that correspond to our value. We can use the unit circle to find the other angles that correspond to our same value of cos, which is minus 1 over 3. We are dealing with negative cos, therefore the only other quadrant with a negative cos is the third quadrant. So our angle is there, and the angle that corresponds to that is 360 minus our first answer, which is 109.47. This means that we have 2 theta equals 109.47 and 250.53. And in order to solve for theta, we just need to divide these two values by 2. The other way to work out the other corresponding angle is to look at the cosine graph. If we go to minus 1/3 in the cosine graph and draw a straight line, the first point it hits the graph should be at 109.47, but there should be another one on the other side of the graph. If we continue the straight line, it should hit the graph there, and since it's symmetrical around 180, the other angle that gives minus 1 over 3 must be 360 minus 109.47. Therefore, we have the same answers for both methods.